Glad to be here and thank you for having me. I'm sorry I'm late. Thank you for whoever saved a burger for me. It really helped. And so I'm going to talk about KEDA. By the way, I was just I was preparing I didn't prepare the GitHub repository yet, so I thought why don't let Copilot write the README? So that's you're gonna find it on GitHub soon enough. But that's basically what we do now. We use a lot of Copilot to automate the tasks that we really cannot be bothered with. So this is gonna be the README for the repository, and I'll show you what it's all about. So. I'm sorry that I'm rushing it, but how much time do I have, by the way? Half an hour?
Plenty.
Plenty of time. More than I need. So it's me, I'm Alessandro, I'm a colleague of Pascal and Joran here. Anybody else from Microsoft in the room?
No.
Okay, it's a small club. I just rejoined Microsoft, so I'm a boomerang. I was there for 7 years. I saw a lot of things in the first 7 years at Microsoft. I saw AKS coming up, API management. There was nothing, and I'm really glad I was there. And I left, and I regret it, and I'm back. So really happy I'm back. No regrets, but it's a great team. We're doing amazing stuff with AI, with cloud native, with Kubernetes, which I'm gonna talk about soon, right now. So, small agenda, KEDA overview, why autoscaling matters, and because this is an integration meetup, I decided to do a demo on Service Bus, right? So, Azure Service Bus is one of the tools we have for PubSub and message passing between applications. Why autoscaling matters, right? So, it does matter, right? So this is also why the cloud was born, right? So who remembers it was Amazon sitting on a bunch of servers, they were not utilized. So they say, why not giving them away so we actually can track more closely this utilization with the capacity that we have. So most companies, organizations operate in this regime, right? So they just have a fixed capacity and the load is changing, right? So it's simple. You don't need to change capacity all the time, right? So it's probably your data center looks like this. It takes months between this can go up, never goes down. I mean, unless you throw away servers. But for this to go up, it takes weeks or months or years. And while it's fixed at one level, then you have these two problems, right? So either you are underutilizing what you have, right? So you are leaving money on the table, you bought more than you need, in case some peak, some time appears, and then what? Or you are under provisioning, so your load is higher than what you have available. Both are bad, right? So one is expensive, wasteful, and I'm talking about your wallet, but also the planet, right? So CO2 is emitted no matter what. Server standing idle in the data center, they still draw power, maybe not a lot, but a significant amount of power. And you just don't know what's going on, right? So you have all this capacity unused in some place, and maybe you are underutilizing it in some other places. It's really not the best way. And of course, if you are all of a sudden into a peak, but you don't have auto-scaling, you don't have elastic capacity, then your user is gonna notice, you're gonna have latency, and this thing tends to cascade, right? So one server falls down, the remaining servers or services, they have to pick up the slack, and it just gets worse and worse, right? So if you, for some reason, you are in a DDoS attack or it's Black Friday, it's not where you want to be. But why are you do it, right? So this is what you want to achieve with your data center if you can, in the public cloud, of course, this is at your disposal. We also don't see this in public cloud. People tend not to do this. They create AKS cluster without auto-scaling for some reason. And so they just throw it there and they don't really take advantage of the dynamic nature of the cloud. But this is very difficult to achieve. Well, not difficult to achieve because we got the tools, and I'll show you why it matters. So, Kubernetes, who loves Kubernetes? Love Kubernetes, not like. See, okay.
I love it. I love it.
I do. I run the Dutch Kubernetes meetup, so that's also a CNCF ambassador. I really do Kubernetes all the time. There are 3 dimensions of scaling, right? So when you say scaling, what does it mean? Historically, there's this the horizontal scaling and the vertical scaling, right? So make server bigger, right? So just add more RAM and CPU if the server allows, and horizontal scaling, just add more, right? So just make, if your application can be horizontally scaled, so there is no persistent connection to database and that sort of stuff, horizontal scaling is better because a single server can only take so much RAM. I mean, I've seen 2 terabytes and maybe more, I don't know, but they can get big, but not bigger, right? So there's a physical limitation of how much resources a server can take. In Kubernetes, you get the same idea, right? So 3 dimensions of scaling. One is horizontal auto-scaling, or horizontal auto-scaling, where you just deploy more copies of the same pod, right? So it's the same pod, the same template, exactly the same application, just repeated more times. And the beauty of having an orchestrator is that these things are easy to achieve, right? So you just have now you have one pod, you just change a number in the definition of that deployment, and now you have 10 pods or 1 million. It doesn't really matter. Kubernetes, it will just take your request of new pods and just try to place them in the right place, in the best place possible, that's so to say, through the scheduler. Vertical pod autoscaling is also a dimension and is a semi-official Kubernetes project. So it's not part of the core Kubernetes. So you don't get the vertical pod autoscaling out of the box, you have to install it. But what it does is that the same pod, in Kubernetes you have limits and requests. So it dynamically changes the limits and requests of your pods. What does it mean? If the pod, let's say that you're running Java, you should not, but if you really have to, Java eats a lot of RAM, right? So, and that tends to balloon. And then if you don't set the limits very generous, because of course you don't want the request, for example, to be too big, because otherwise the scheduler will not find a place. If you say that my pod needs 10 gigabytes of RAM, means that the scheduler has to find a node with 10 gigabyte free. And if there is one with 9.5 gigabyte free, the pod will not be scheduled. So that's a big problem. So the vertical pod autoscaler solves this problem by dynamically changing the limits, the size of the pod. And finally, of course, all this happens in the cluster, right? So you don't need to buy extra stuff. You don't need to pay extra for this. But the cluster autoscaler, of course, is where, of course, you gotta start paying for resources, because it just adds more nodes, makes more space for your pods to exist, right? So, but of course, it's usually these cluster autoscalers, they talk to the API of your cloud, Azure, AWS, just request more nodes. And ideally, when the load is gone, it will give back to the cloud the nodes that you don't need. So the scaling goes both ways. So the horizontal pod autoscaler will increase the number of copies of the pod, but when the load is gone, it will try to also destroy the copies that you don't need. Right? Anyone?
I have a question. So I'm running my API, my microservice API. Yes. Most of them, maybe the customer is using Azure Functions.
Yeah.
I'm just wondering, right? So if I want to run my microservice API, why should I go for AKS instead of Azure Functions? That will be my first one. And if I want to run my API in Kubernetes, which kind of scaling should I use, or which kind of scaling would be most appropriate for an integration?
None of this. KEDA. that's so the last one.
Good.
Because these are very crude scaling, right? So it's only the assumption is I'm eating the API so much that the process is consuming more resources. So the CPU or RAM goes above a threshold that triggers the auto scaling. It's very crude proxy measurement for user experience.
Yeah.
So we assume if a process is using 80% of the available resources, then probably is also experiencing a lot of load. So probably the response, the latency will be bad, and so I need to scale. That's the general idea. It works most of the time, but KEDA, which I'm going to talk, is a bit more sophisticated. It just goes into more detail.
Cool.
Serverless versus containers.
Yeah.
I remember, I'm 49, when I was a kid. 2016, let's say, 2017, the year of the serverless. Every year since is the year of the serverless. And what are we running now? Containers. So, does it make sense? Sure, you should run your application as much serverless as possible, no more than necessary. That's the idea. I know it's confusing. I mean, not all application can be functionalized, can be placed into a serverless function. Not all application, but all application, at least the one I know, except the one with the GUI, can be put in a container. So serverless applications are a subset of the application that can be containerized, which is a subset of the whole collection of applications. But many more can be containerized than let's say, chunk into functions. So if you can do it, by all means, sure, everything should be a function, but it's not. I mean, what we see in the field is that the adoption is hard. You have to refactor your application. Developer times is precious, and so people just put them in a container, call it a day, running in Kubernetes, is working, going home to have a beer.
Yeah, it depends on the customer as well, of course.
Yeah, of
right?
course.
So if you have bigger customers, they already have a Kubernetes cluster, an AKS cluster running, and they say like, please, we're not going to use Azure Functions because we already have containers.
Yeah, so why would I? It's an investment. How much return of my investment in time and money? I'll just stick to Kubernetes. You know.
Thank you. Yeah.
Good for me. As an expert, right? So, but I'm not. I didn't marry Kubernetes, right? So it's not my wife or so on. So I'm okay to when it doesn't make any sense. I'm very clear. No, it doesn't. Don't do it. So why it's not a pod outscale is not enough? Because it doesn't scale to 0, right? So it's not. So you always have to have at least one copy of the container. It's only limited to CPU and RAM, which is it's okay. It's not for many use cases, but why can we be more accurate in our scaling? You know, because maybe by the time the pod use 80% of the CPU, maybe it's too late. Maybe my application is crashing. Maybe my users are experiencing latency. I don't want to go there. I want to be smarter. And of course, it depends on metrics aggregator and so on. So it's there is no sophisticated metric. It's just CPU or RAM. That's it. So 2019, I was there. I was at Microsoft. This project came about. I mean, they open source this project called Kubernetes Event-Driven Autoscaler. So this is 2019. This is the new Microsoft. First thing we put it on GitHub. We ask questions later, right? So first we open source it, see if people like it, and people did like it a lot, and then let's build a community around it. And that's what happened. This is a perfect story of a open source project born in a big company, but then took a life of its own. Right? So many contributors now are not even working for Microsoft. They are Red Hat and AWS and so on. Was donated as a, so that's how it works. You have a project, you can donate it, like take it, and then the project goes through a series of steps or phases. So Sandbox is just my hobby project. It's not gonna work. I don't know. It's probably gonna blow up your clusters. Incubation is that this works. This is good. There's a community around it. Everybody's happy. And graduation is production grade. So this is production stuff. So it's a component. It's an operator, right? So something that you install in your cluster to auto-scale your applications. And it's a pluggable system. It got more than 70 autoscalers. And let's see how it works. So it's very simple. It takes an input from an external trigger source. Can be any of these 72, actually, maybe more next week, I don't know, will trigger an event. And then KEDA, the controller, will, you define the scaled object that are attached to a existing object in your cluster, for example, a deployment or a job, and then KEDA will create, for example, in case of deployments, a horizontal pod autoscaler that will scale your object. I know it's a bit complicated, it sounds complicated, but actually it's very simple. There is an event, the event triggers a reaction from KEDA, and KEDA does what it's supposed to do. Scale, according to the rules you set, that object. That object being usually a deployment, but can be also other kind of objects as well. So the feature is that event-driven, so it's not a metric, it's an event. The event can be HTTP request, or in our case will be Kafka queues passing a threshold, right? So that's and there are many different kind of events, and the scalers they define these kind of events. And of course, it's vendor agnostic. It can also scale Azure Function, by the way. It's not the theme of the talk, but these are the scalers and KEDA scalers. Something like that. You can see there is a bunch of scalers out here. You name it, of course, a lot of Azure stuff, but also InfluxDB and MySQL. So these are like connectors, right? So they are kind of plugins that takes a ready stream and triggers. So of course, every scaler has its own configuration. You need, I don't know, the password and username and where is the Redis server, of course. But then it works very, very well. And of course, one of the most popular is Prometheus. So you can, any query you can do in Prometheus can be translated into an event that can trigger a scale up or scale down event in KEDA. And what we're going to use today, of course, is our favorite, Azure Service Bus. Who use Service Bus here? Integration.
You could have guessed it, right?
So I don't need to tell you what Service Bus is. That's at least one less slide to show. But this is how it works. So you have this scale object, and it's kind of connecting an event source with an object. So the scale target reference says, well, what I'm going to operate on is a deployment, and this is the name. And this is simply, there are many other options you can specify. For example, the cooldown period. After you scale up, you want to cool down and don't just scale down immediately. You want to be a bit gentle, right? So but you can set the two maximum and minimum. And for example, this is just a number of HTTP requests. If it's above 100, this is triggered, right? So, and then triggers a scale-up event. There's also scale jobs. I'm not going to talk about it. Or, for example, this is we always try to do this in so many ways. Before KEDA, we had to invent like cron jobs and things totally crazy. But this with one object, right? So I'm just attaching basically a cron to my deployment. So I'm saying here, every day at 6 a.m., between 6 a.m. and 8 p.m., scale to 10, right? So scale to 10. So I don't even want to be sophisticated. I don't want to, but instead of me waking up, drinking a coffee and pressing the button, this is gonna do it for me, right? So no matter what, as long as it's 6 a.m., the rep can go up. You can do this in other ways, like I have a cron job that calls the Kubernetes API, sets so, but this is simpler, right? So this works. And why scale to 0 matters? This is from a guy from White Duck. He demonstrated how to scale GitHub runners based on the GitHub queued jobs. So think about it. I'm having my private runners. I don't want to use GitHub infrastructure, but I don't want to keep them running all the time. Maybe my GitHub runners are pods in my Kubernetes cluster, right? So why? So no jobs, no pods. First job comes in, the queue goes up. I'm spinning up a runner. The runner goes up, does its job. If more jobs are being queued, more runners are gonna come up until the queue goes to 0, right? So these are very smart, and this is important. So you don't need to keep runners up just waiting for jobs to be queued, right? So you can just stay at 0 because KEDA aptly scales to 0. And by the way, this example doesn't even use AKS, use container apps, which is kind of the same thing. And why is important for me? If you see the sticker, tag environmental sustainability, I'm particularly interested in green. I have kids, and there's only one planet, and I want to leave it better than I found. It's not gonna happen, but at least we can try. So there's also a project called the Carbon Aware KEDA Operator. It's also using another project from the, so I'm a tech lead at the Technical Advisory Group Environmental Sustainability, which is a group within CNCF that talks about green software. I'm also a green software champion from the Green Software Foundation. So if you want to know, if this is going to be all another night about how to make our software greener, this is one way, right? So scale it. If you don't need it, kill it, right? So, and this Carbon Aware KEDA Operator does exactly this. It takes from outside, it takes the carbon intensity of the software you're running and makes a decision based on, it feeds into KEDA what it should do with that information, right? So, so you can make sure that you are following best practices and the software, the SCI, the software carbon intensity from that particular data center, but it's all. This was also announced like a couple of years ago, didn't get a lot of traction, but I hope more. And I just made this. Imagine, so we're doing AI, I mean, that's what we do, right? And Microsoft today is all a copilot. Imagine your model is running, right? So, and then you want to check, maybe we have Azure AI Foundry, which is a great tool to manage and do a lot of interesting things with AI. Also has an observability side, right? So you can actually get information and metrics about the quality of the model. Maybe, and if you monitor that, and maybe you notice that the quality is going down, and the model needs retraining because things change and maybe it's not working like expected, you can constantly monitor the quality of the model, of the responses, feed it into KEDA, and KEDA can trigger a redeployment, a retraining. Where do you train models? On Kubernetes. OpenAI famously runs one of the largest clusters, 7,500 nodes in AKS to train ChatGPT. So you can do it too with another tool, also very cool, called Kaito, Kubernetes AI Toolchain Operator. Don't need to bother you, but it's another tool from Microsoft, also open source, that automatically provision GPU nodes so you can run your LLMs, and you can also train and do inference on those LLMs. So I haven't built it yet, but it's definitely something we can build together. So service bus. I didn't know much about it, but now I do. So service bus is our, of course, like a pub sub service, and you can use KEDA to trigger when, for example, the queue goes above a certain threshold, which means you don't have enough consumers, so you are making a lot of messages, but there's nobody or not enough people consuming those messages. So you can auto-scale the consumers based on the amount of messages in the queue. So and now for the demo, of course, so we're gonna just we're gonna also use Azure load test. Who use Azure load testing here? Okay, that's cool. Also, I didn't particularly know much about it, and I had to use JMeter to write the test. So I think I deserve applause for that. So this is our service bus. There is a queue in there. It's very simple. I created it. It's nothing special. By the way, the queue has also auto expiration, so it doesn't just keep messages in there. And what's the most interesting for us, of course, we have a Kubernetes cluster. Can you see? Is it visible?
Yeah.
So this is a consumer app, right? So this is a deployment. This consumer app, the deployment says there is a replica 1, right? So very simple. There's one guy consuming messages. All right, that's will it be enough? That's my question. So let's see. I have a load test, Azure load test. Very interesting thing. So it's a test that I created via JMeter. I had to upload also the plugin as well, the jar file. Anyway, it's ready to run, right? So I think I've never run it. Okay, whatever. So I'm running the test. You can run it for many. You can set the amount of time and so on. I don't know. I think it does 500 per second. We'll see. I'm starting the test. So while the test is running, and we go back to our. You can see, I think it's already, this one is already, yeah. You see the connection coming up. By the way, I set up Azure Grafana, Azure Managed Grafana, because I like, it's a bit slow in capturing, because it's using the Azure, this is using, if you know Grafana, do you use Managed Grafana? It's a very awesome piece of software. You use the Azure Monitor connector. Right? So it's a bit slow in capturing the actual, but soon enough you will see also in Grafana the amount of messages coming up. So the amount of messages is, you can see the demo queue, see, 1,000 messages. Right, so 1,000 messages. this poor guy over here is trying his best to process, okay, but is not enough, right? So it just doesn't have enough capacity. So what we're gonna do, bear with me, also, thank you Copilot for writing the README for me. So I created the deployment, this deployment, and I created the trigger authentication. So the trigger authentication is just a object that tells KEDA, hey, if you need a credential for the service bus, is there, right? So I have it here. Trigger authentication is there. So I just had to create it. So KEDA needs to know the number of queue, the message in the queue in his authentication. So that's why I created a secret and so on. And now I can create this scale object. The scale object, see, 10 to 0. All right, so let's see. Scale object created. Oh, better yet, this is the number of consumers. You have to, there is 10 seconds waiting time, so it doesn't just go and make something. 900, because this one guy is catching up. I hope I will have enough messages by the time. Let's see. I can also start another test run, of course. Let's see. It did work before. It just takes some moments. Let's run another test run. Okay. You can also configure the test to be the low to I'll just leave it like this, of course, and then I'm gonna run another one, call it 2. So hopefully this should be enough to really kill my my queue. It's always hard to find the timing, the exact timing, but trust me, eventually we'll get this number to go up. I can also do this, and I know it's gonna work. Okay, that's give me a second. Yeah. Okay, well, so let's see how the queue is going. Yeah. Is it running this thing in? Not started yet. I think there's a parallelism. Wait. Second. Okay, let me start JMeter. My own local JMeter is a bit more, I configure it to have a bit more strength. I can configure it to have more threads and more, so I can really kill or try to kill the queue. So this is the test plan in JMeter, and I can say look for 300 and go to 200. Let's go. So you can see there's a bunch of things going on. Now we are talking, right? So consumer min max ready false. Sorry, there's something wrong with the scaled object. What did I do wrong? Notification Q. Sorry. So I was using environment variable, but that wasn't defined. So now that I did this, now ready true, and after the, because now we have a lot of messages in the queue, right? Yeah. I didn't dream this, right? So it's scaling up, and each one of them is consuming more and more messages, and eventually it will be much faster. See, the queue is gone because now I have 5 consumers, right? So I can also try with more if you bear with me. Then it's gonna scale to, you see, it scaled to 0, by the way. When the queue was gone, because now I have a scale object, and now it's scaling to 1, because I'm pushing more messages. Yeah, but it's so fast in consuming that in a few seconds, the queue is gonna be taken care of. And apparently in a little bit it will also delete these pods. Okay, that's the demo, which it did work, right? So, yay! Kind of, I mean, it does work. Anyway, so that was me. IMS0 is my GitHub account. Soon enough, maybe tonight, I'll push the instruction to replicate this amazing demo about KEDA, and that's about it. Any question?
Yeah. So what was the trigger? Is your KEDA, you're pulling the service plus queue, or is it a trigger from service plus queue?
This one is pull, as in
Okay.
KEDA is polling.
Okay.
It's in the code, right? So what is it? Polling interval 5.
Oh yeah, yeah. Okay. Line number
so
1.3.
polling interval, yeah, polling interval. Yeah. So, but there is also HTTP trigger that can be like a webhook.
Yeah.
So you can push a message, and then KEDA will. It's an event.
Yeah. Yeah.
And that's is recently added to KEDA, and it's very powerful. It's like imagine having a webhook for your pods. Cool stuff. Any more questions?
So you showed us a lot of potential event triggers.
Yes.
The HTTP one, is that an HTTP request that goes to, for example, a web server? If I send you a lot of messages or a lot of events on a service bus or whatever, and you use push, that will cause a big load on the back end to verify, oh, am I too busy, am I too busy, am I too busy? How do you handle that? I can see it from the polling perspective. You just showed on the previous question.
Yeah, the polling is
If you
done
do it
by
with a push one, it might be better in scaling. But on the other hand, if I query the service bus for how many messages do you have, that's a heavy request as well. So I might kill my performance the other way.
Yes, but this is I mean, 5 seconds pretty frequent, right? So default is like 60 seconds, right? So depends on your application. Do you want to really immediately react? This for the demo, I put it down because I wanted to show quickly. I didn't want to wait a minute, but I would keep it. do you really need to respond in a...
Mostly not.
Mostly not.
Mostly,
So a
1
minute,
minute
I
is
think
enough,
is...
I guess. Yeah.
If the queue is going up, it depends also, I mean, who is making these messages. I mean, of course, it's all stored.
If you have a queue, you're already asynchronous processing it. So
Yeah.
that additional minute mostly
Won't make a difference, but
Sure.
it may make a difference. So,
Sure.
but the thing is, the beauty is that you got all the knobs to change if to fit your use case of instant reaction versus okay, I can wait a bit. I mean, also maybe it's just a flake, you know, just a fluke, just one event like a I don't know, cosmic rays or something, right? So then it's gonna go away. But okay, that any more questions? It's getting to 0 again. And 1. I think my
Second one running.
still running, right? Yeah, 400 producers. So that's not gonna. I think I'm gonna have to kill it. But see, like it's not even fulfilling the old.
Think
The old
about the
tank.
environment. Think about the environment. Kill it.
Renups.
5 kilos of CO2 wasted. Hey, no, but you having fun, so. All right. Okay.
Cool.
That's it. So if you have any questions,
There's something for you. Thank you so much for the presentation.
little something.
Little something.
Hey, because it's my birthday next week. So.